Everyone, this is Dragonair team. I am Şeyda Aybar and my teammate is Ayşe Çelik. I will talk about our project Deep Audio Classification. Dragonair team is interested in chatbots, music genre identification, and visual assistants, etc. Therefore, we decided to an audio classification. In this study, a model has been developed that can perform audio classification and detection. Audio files belonging to a bird species called capuchin and some forest audio recordings were used in this study. After going through various preprocessing steps, the audio files were converted to image data so that they could be used in the CNN architecture. Spectrogram method was used to convert our audio files into image data. With the developed CNN model, the audio of the capuchin bird was classified, and it was possible to determine how many capuchin sounds were in a forest sound recording. We found our data from the Kaggle. Name of data is the by HP Unlocked Challenge 3 signal processing. The data set consists of the capuchin bird species sounds bar and sound files without the sound of this bird. The sounds in these two folders are in WAV file format. In addition, this data set contains recordings of sounds found in the forest for use in testing operations. The files in these two folders are 2 or 3 seconds long. In these forest sound recordings, the sound of different bird species can be heard along with the capuchin bird. These files are in MP3 format. These recordings are approximately 3 minutes long. I wanna show you our dataset samples. You can see there is forest recordings, and I will show you a capuchin bird sound. Okay, let's open this. Again. Okay, I think it's enough. Let's continue our methodology. You know, our project is audio classification project. So let's see what is audio classification. Audio classification is one of the most widely used applications in audio deep learning. It involves learning to classify sounds and guessing the category of that sound. This type of problem can be applied to many practical scenarios: to classify music clips to determine the genre of music, or to classify short phrases by a set of speakers to identify the speaker by sound. In our project, we are trying to understand whether there is bird sound or not. Let's get started. First, we performed some processing steps to be able to use the audio files in later stages. We have reduced the audio files to 16,000 Hz and 1 channel. We also have reduced the audio file size. In short, we have brought the audio files to a format that we can work on. We performed these operations with TensorFlow decode wave method. We convert audio wave into an image representation to able to use data in CNN architecture. Then we created a TensorFlow dataset. We added labels to the dataset and combined the positive and negative instance. Thus, the data is ready to be used. We used TensorFlow to convert the data to spectrogram format at the image representation stage. At this stage, we have carried out some preprocessing of the data in order to be processed better. We use spectrogram method to convert our sounds file to image format. What is spectrogram? A spectrogram is a visual way of representing the signal strength. You can define it briefly. A picture of sounds. You can see a sample of a spectrogram here. It's you can see from here what does a spectrogram look like. For this project, we have used CNN architecture. Our model consists of convolutional 2D dense and flattened layers. We have used ReLU activation function in our model, but we have used sigmoid function at the last dense layer because we need a binary output as 1 or 0. We have used ADAM as optimizer and binary cross entropy to calculating loss at the compiling stage. This is a basic definition of our model. You can see from here what we use in this model. We have done some experiments while conducting this project. A route map to be followed while making audio classification was created. Since the sound files cannot be directly input to the model, the use of spectrograms has been studied and tested in detail. No problems were encountered while performing the steps. However, an out-of-memory error was encountered while the generated spectrograms were given to the model. Solving this error has been our priority, and literature searches have been made to handle the work out-of-memory error. Despite using batch size and changing this batch size, this error has not been resolved. However, experiments have been made by reducing the number of our data. We made the last point of our experiments by reducing our data number to 1, but still the out-of-memory error could not be resolved. Out of memory is an often undesired state of computer operation where no additional memory can be allocated for use by programs or the operating system. Alternatively, we continued our experiments by breaking up the project. The project consists of 3 different studies. 2 of these files were made to generate spectrograms. The first file converts wave files to spectrogram. You can see from here audio to image. We convert our capuchin bird voice to a spectrogram in the different file. The first file converts wave files to spectrogram, as I said before. The second converts MP3 file to spectrogram and saves this spectrogram image as PNG file. The dataset was made ready with the images obtained in these 2 work files. Since we want to ensure high accuracy, we have experimented with different batch sizes. When the batch size is 16, we have seen that we have achieved the highest accuracy and the work has continued in this way. By examining the loss value, it was understood that there is no memorization situation, and the studies continued with the test data. Finally, the spectrograms of the 3-minute audio files created by first recordings were examined, and it was tried to estimate how much bird sound was in them. And you can see our second file, first recordings to image. We do this operation in different file as well. This is our model. You can see our model architecture from here. These two are our convolutional 2D layers. We have 2 convolutional 2D layers and 1 of flattened layer and 2 of them dense layer. And we use here ReLU activation function. Then we, for output, we use sigmoid activation because we want to see a binary output, a 1 or 0. Result, we can see our loss values from this plot. And we have a very good loss for our project, and this means that we have a high accuracy as well. and we classify our sounds very well. And thank you for your attention and your listening. Have a nice day.